Hello, welcome to all my dear students, my friends. In previous lecture, we have already seen about the basic concept of the mechanics of material. That means from what the mechanics of material will arises. The mechanics of material is nothing but the origin from the mechanics, engineering mechanics. That will I already told you in the previous lecture one. Okay, now we have to proceed for our syllabus. Now the previous introductory lecture will be very helpful to you. I think so. So we are proceeding here for the syllabus. See, the first unit is nothing but the simple stress and strain. Okay, then what what it includes? Let us see here. We have seen in the last lecture overall syllabus. Now we have to proceed for the unit wise. Okay, in that see here unit 1 first content. See on the screen sharing mechanical properties. This concept of direct bending, shear stress, strains, stress strain relations, biaxial and triaxial loading, elastic constant, and their relationship, stress strain diagram, and their characteristic for mild steel and other metals and factor of safety. Okay, next one, that is the uniaxial stresses and strains. As I told in the previous lecture that the stresses and strains are severally classified on the basis of the line of action of the forces, or on the basis of the type of the forces acts on it. Okay, and what type of stress is created over there. So it includes the different types. We will see in our next lectures. Now see here uniaxial stresses and strains. It includes the stresses and strain in compound bars, uniaxial tension, compression, temperature stresses, simple restraint bars, and compound bars of the two metals only. Now see here, this is total unit 1 syllabus. Okay, now we have to follow the syllabus point wise, and we have to describe each and every point over there. On the Google Classroom, I already shared the 3 lectures slides. Okay, if you have joined the Google Classroom, you will be get all the reviews about the PPT which shared by me. Okay, you have to go through it, then you will able to understand what I am saying. Okay, now see, before going this, or before starting the concept of the first unit, the first unit is nothing but the simple stresses and strains. Here, first of all, the basic things which are you must know is I am sharing now. See here, in the previous lecture I also told you the conversion factors are very important before solving any type of problems, before solving any types of concept in this especially for the first unit. See here, the page shows on the screen. Here the conversion factors are given. It is the kilo, mega, giga, tera. The kilo means 10 to the power 3 and represented by the K, then mega, giga, tera. Okay, these conversion factors are very important because in the problems, the value of the stresses are given in various forms. That is in pascals, in Newton per meter square. Then you have to convert in the Newton per mm square. Okay. Here these are the positive conversion factors, and here the negative conversion factors. Here milli, micro, nano and pico, and symbols are also given to us. Okay, now on the Google Classroom I also shared this page. This is from the book of the R.K. Bansal. This is very basic book for the strength of material or mechanics of material. Okay, so these conversion factors are must known to you before appearing the problems and before appearing the any type of concept. Okay, so first of all, see, now we are dealing with the simple stresses and strains, and we have also seen the syllabus. What type of syllabus is here? Okay, see here, this concept is already told to you. The branches of engineering mechanics here, you already seen that the mechanics of rigid body and mechanics of deformable body. That means the whole solid mechanics is divided into the two types. Okay, now in last lecture or in the last year we have seen all the mechanics of rigid body. Now we have to consider, or we have to take your focus on the mechanics of deformable body, that is strength of material or mechanics of material, and in which that your first topic is nothing but for the simple stresses and strains. Okay, these are the objective topics regarding the concept. Okay, now we have to start the topic from the properties, mechanical properties of the section. That means sections, here section is nothing but in different types of metal, different types of material we have to use here, and we have to test it out for the different types of testing. Okay, so each and every material having several properties regarding the structure, regarding the shape, regarding the chemical contents, regarding the behavior towards the load. Okay, these are several properties. The first one, see here, elasticity is the ability of material to gain its original size and shape on the removal of the roll. Okay, it's already known to you. Okay, it's very basic concept for the elasticity. Elasticity is nothing but it is the property of the material in which the material get, or the object, suppose consider here the object gain its size and shape on the removal of the applied load, then this property of the material is nothing but the elasticity. Okay, next one is the plasticity. Plasticity exactly opposite to that of the elasticity, that means which is not able to gain its original size on the removal of the load. Okay, that means त्याला आपण म्हणतो plasticity. That means the material is in plastic state. If the material gain its original shape and size, then material is known as then we term is that then the material is an elastic state. Okay, and if the material is not able to do so, then the material is in plastic state. Okay, next, ductility. Ductility means the material can be drawn into wires. Okay, the material that can be drawn into wires is known as the ductility. That means we called it as a ductile nature. Then brittleness. The material is brittle if fails under the load and impact without showing the appreciable deformation. Brittleness. Malleability. The property of material of getting deformed permanently under compression. Hardness. The ability of material to withstand scratching, wear, abrasion, indentation. That means all types of the weathering agencies, or all types of agencies which cause the losses for the respected material, then here it's shown as the wear, abrasion, indentation by the harder bodies. If this type of agency will not affect it, or will not affect to the specific material, then we told the material is an, or we decided that the material is in hardness stage. Okay. Last one is the toughness, the amount of energy that can be absorbed before the failure is known as torsion. These are the mechanical properties. Okay. Now we are proceeding towards our the main topic, that is stress and strain. That means this unit totally includes the stress and strain. Okay, and severally when we proceeded for the successive lectures, then you will get the type of the stresses, type of the strains. Okay, first of all, stress is nothing but stress means what we called as the stress. Stress is nothing but the if any type of object or any type of body is having in your hand or having in front of you, then you will try to create a pressure on it, or you will try to create, or you will try to apply the load on the respected body. Then the body or the object which is in front of you having tendency to regain or to oppose the force caused by you or applied by you, then this tendency is nothing but the internal restoring force which can be present in the object where you are applied load. Then this tendency is nothing but the stress, or this tendency per unit force is nothing but the stress. See here, the definition says that the deformation means when you are going to apply load on the certain body or certain structure, then the structure tries to oppose the load. Okay, so this deformation is opposed by the internal force which can be present in the object, and this deformation per unit area with respect to the area means cross section area. If there is a square, then and you are applying the load on the topmost area of the square, then the total force or total load upon the area is nothing but the area of square, that means A into A, then you will call it as a cross sectional area. That's why I repeated here, it is nothing but the deformation per unit area is known as stress. That means stress is equal to force upon area. In short, for good remembering, listen. Stress is denoted by sigma. Sigma is equal to force upon area. Then the force is nothing but the internal restoring force which opposes the load comes on the object. Okay, then this property is the property of that material where you are applying the load. Okay, or it is the property of the object where you are going to apply the load. This is known as the stress. या प्रॉपर्टीला आपण म्हणतो स्ट्रेस. therefore stress is equal to sigma is equal to stress is denoted by sigma. Sigma is equal to P by A किंवा F by A. That means load upon area or force upon area. So here, listen here. The mathematically the stress is defined as in simple form force per unit area or the applied load per unit area is known as stress. Stress is denoted by sigma. Here sigma is equal to P by A. Okay, where sigma is the stress induced in the body, P is the load or force on the body, and A is the cross section area of the body. Thanks.